Welcome to the Lessons from Lab and Life podcast from New England Biolabs. I'm your host, Lydia Morrison, and I hope this episode offers you some new perspective. Today, I'm joined by a very special guest, the 2023 Genes in Space winner, and an incredible high school student, Isabel Jiang. And joining Isabel are her mentor, Alex Radakovich, who's a graduate student at Harvard University, as well as Mark Bliss, the Mini PCR Bio Genes in Space program lead. Genes in Space team and the 2023 Genes in Space winner, Isabel, thank you so much for being here today.
Yeah, thank you so much for the opportunity and for having us today, too.
Great to meet you.
Great to meet you.
Isabel, could you share with us how you heard about the Genes in Space competition?
I learned about Genes in Space through a STEM club at my high school. I actually competed last year in 2022 as well, and there was a local high school near us who had a few of their students named as honorable mentions in the competition, and that's kind of how my STEM club at my school found out about it. So I competed last year with one of my friends who has now graduated from high school, but we were named honorable mentions last year, but I really loved my time in the program, and I wanted to keep exploring, keep seeing what else can be done in space, so I competed again this year, and now we're here.
Congratulations on your win. So incredible. What's it been like working with your mentor, Alex?
It's been a really, really phenomenal experience. I wouldn't be here today without him. He's provided a lot of feedback in kind of guiding my experiment and all the different pathways that it's taken from my initial proposal. And he played a significant role in kind of that really scientific experimental part. And he also helped me a lot in my presentation skills and being able to more effectively communicate my ideas at my final presentation at the International Space Station Research and Development Conference. And he's just helped me grow a lot as a scientist and also as a communicator and a presenter. So it's been a really great experience having him in my corner.
Oh, that's so wonderful. And I have to say, seeing your presentation this morning, you're an excellent presenter. So I think you're definitely absorbing all of those skills and teachings that he's offering. I would love if you could tell our listeners about your experiment.
Yeah, so my experiment is focused on retrotransposons. Retrotransposons are a type of our DNA. They're called mobile DNA elements more formally, but informally, a lot of people like to call them jumping genes because they can literally jump from places in our genome to other places in our genome by literally copying and pasting themselves. So these retrotransposons or jumping genes have the power to interrupt a lot of important genes. If they become activated, they can kind of jump into a lot of genes that are really important for human health. For example, one type of gene that retrotransposons have been shown to paste themselves into are tumor suppressor genes. So if retrotransposons become activated and paste themselves into a tumor suppressor gene, the tumor suppressor gene is no longer functional, and that patient is more susceptible to risks of cancer. So retrotransposons are the focus of my experiment, and usually retrotransposons, their activation is kept at bay on Earth. Our body has really strong internal control mechanisms that prevent them from being activated. But in space, I'm hypothesizing that factors like radiation and microgravity can cause our body's internal control mechanisms to become dysregulated, and retrotransposons, as a result, can become activated, and they can wreak absolute havoc in our genome if that happens. So my experiment is focused on studying the activation of retrotransposons and their behavior in space.
And what has the process been like in terms of your initial proposal to the experiment that you're working to send to space now?
It's been a really long process, and there have been a lot of changes to the various experiments. My initial proposal that I submitted back in April was very different from the proposal that I presented at the International Space Station Research and Development Conference in August, where I competed to win this competition. And even from there, that proposal is significantly different from what we're actually launching into space. So the experiment we're actually launching into space is more focused on developing assays to study retrotransposons in space rather than simply studying them. But these assays also have a lot more applications in other fields of research as well, which I'm really excited about.
Yeah, I'm really excited about it too. I can't wait to hear what the results of the experiment are and how they can help drive research in science in space forward. What's your favorite subject in school?
I mean, for me, it would have to be science, but I've always really loved biology, and I've loved a lot of different aspects of it. I found myself gravitating more towards the different applications of biology and other fields of science recently. So I've taken a few really amazing chemistry classes and physics classes in my high school, and I'm a little bit interested in how biology can be applied to those principles. And I'm also really interested in medicine as well. So kind of biomedical sciences and the way that biology can inform medical research to create actual treatments.
Sounds like you maybe already have some thoughts on a career trajectory already. What are you hoping to do in the future?
Yeah, so I definitely want science to be a really big part of it. I also love that science can be applied really easily to helping other people. So for me, my ultimate career goal is becoming a physician scientist, which is someone who can both treat patients as a doctor in the clinic, but also has their own lab and can work on developing treatments and researching to create cures for a larger patient population. So that involves getting an MD, PhD, and I'm really excited about the opportunity to go down that career path.
Well, I'm really excited to follow your career path and see all of the amazing things that you do in the future. Thanks so much for being here today.
Yeah, thank you so much for having me.
Alex, how did you learn about the opportunity to become involved with the Genes in Space program?
So I learned about this amazing opportunity through an email to my PhD program. I actually first read the email and forgot about it and didn't really take it in until one of my best friends came up to me that evening and said, "Did you see that email about space research? I feel like that's right in your wheelhouse. You would be a great mentor for that." And so she really brought my attention to it. So I reread the email again and then decided to apply for this.
Oh, thank goodness for friends, huh?
Yeah.
So how long have you been with the program?
So this is my 4th year.
Amazing. And how many winning mentees have you had?
This is my first one, actually.
Yay! Congratulations to
Thank
you
you.
as well. What has the experience of working with Isabel been like?
It's been amazing. I could not have asked for a better mentee here. I have learned so much from her, and I'm so happy to have been in her corner. Her ability to process information and to form her own hypotheses has been unheard of, in my opinion. And I learned so much about retrotransposons from her. And I've also learned that presentation skills can be honed and can be done really well through some of the techniques she's been using.
And are retrotransposons something that you were familiar with from your own studies and research, or is it something that you had to learn about as well?
I definitely had to learn about them. I knew about them, and I knew a little bit about the mechanisms that govern retrotransposons and their life cycles, but I definitely had to learn a lot, and Isabel helped me with that quite a bit.
That's great. It seems like you two are a really wonderful team. What has been your favorite part about working with Isabel?
I think the favorite part has to be her presentations. As you have mentioned, her presentations to NEV today was amazing. And just seeing her practice and go through all of those iterations of it and then finally present the final presentation at the conference was just amazing.
Yes, truly incredibly well spoken and clearly a really gifted communicator.
Indeed.
Yeah. So congratulations again on your 4th year victory. And we hope to see you again.
Thank you so much. You will be seeing me definitely.
Mark, I was hoping that you could share with us what the mission of the Genes in Space program is and just some more details about how the program came to be and its history.
Yeah, absolutely. So Genes in Space is a national science competition that was founded in 2015 by Boeing and Mini PCR Bio. And since then, we've picked up additional sponsorship from New England Biolabs, as well as the ISS National Laboratory. And every year, we invite students to propose a DNA experiment that can be done in space. We end up with lots of students who enter. It's a free competition. Last year, I think we had 820 student entries. And of those entries, we select one to be sent to space and conducted by astronauts. So it's an incredible opportunity to meet some incredible students with great questions who are contributing to space biology.
Wow, what an amazing opportunity for young scientists to really feel like their ideas and thoughts and innovations are valued by the larger scientific community. I think it's really incredible. So, in your opinion, what's the best thing about the Genes in Space program?
Oh, absolutely. So every year when we get student proposals that come in, these experiments are really creative. We have really, really great students who are bringing their scientific knowledge to the table, but these aren't just student experiments that are being launched into space. These are experiments that are contributing to space biology. So, for example, in 2015, our first winning entry was the first time PCR was done in space. And a few years later, we had the first CRISPR experiment done in space. So we're genuinely building on what we know about space biology and what's possible. And we're going to need to know that information if we're going to, for example, establish colonies on the moon, or if as we start to build successors to the International Space Station and the research that's being done there. These are students that are expanding those boundaries.
Absolutely. Incredibly important work. Where can people find more information about the Genes in Space program and find out how to participate?
Yeah, so Genes in Space is an annual competition. Our next competition opens January 10th of 2024, and students can apply right from our website, which is genesinspace.org.
And for our listeners who are looking for some further information, you can also visit the transcript for this podcast on our neb.com website, and we'll make sure that we include links to both information about this year's winner, Isabel, as well as how to enter the competition and how to see the amazing projects from the past winners and learn about those. Thanks so much for being here today, Mark.
Thanks so much for having us.
Thanks for joining us for this episode of the Lessons from Lab and Life podcast. We hope you'll join us for a listen again soon.